calculate probabilities in the sample mean distribution, we'll use a similar process that we did with the regular normal distribution. First, we need to realize what makes the sample mean distribution normally distributed. The sample mean distribution will be normally distributed as long as the original distribution of x's is normally distributed, or if we don't know that it's normally distributed, or even if we know that it's not, then the x bar distribution will be normally distributed as long as the sample sizes are at least 30. Once we know this, and we determine that the x bar distribution is normally distributed, the process is very similar. The mean of the x bar distribution is always the same as the original mean. The standard deviation of the x bar distribution is calculated by dividing sigma, the population standard deviation, by the square root of n. The z-score is also calculated very similarly, the differences being that now this value is x bar instead of x. Mu x bar, remember, is the same, and sigma x bar, again, we calculate by dividing sigma by the square root of n. As reported in Runner's World magazine, the times of the finishers in the New York City 10K run are normally distributed, with mean 61 minutes and standard deviation 9 minutes. Find the probability that 20 randomly selected runners will have an average finishing time less than 58 minutes. In the previous video, we looked at the same problem, but we found the probability that one runner would have a finishing time less than 58 minutes. In this case, we want to know the probability that if we selected 20 runners at random and averaged their finishing time, that mean would be less than 58 minutes. So we're looking for a probability in the x bar distribution, or the sample mean distribution. We know that this sample mean distribution is normally distributed here because even though the sample size n equals 20 is less than 30, the original distribution is normally distributed. So we know that mu is 61 minutes, which means that mu for the x bar distribution is also 61. We know that sigma is 9 minutes, which means that sigma for the x bar distribution will be calculated by dividing 9 by the square root of n, which is 20. So we get about 2.01246118. Note that the standard deviation for the x bar distribution is smaller and will continue to get smaller as n gets larger. Anytime you increase the value of the denominator of a fraction and you keep the numerator the same, that value will continue to get smaller. So here we're looking for the probability that x bar is less than 58. So if we sketch this with a mean of 61, we need to find the z-score for 58. So we have 58 minus 61 divided by the new standard deviation that we calculated. Remember that we're still looking values up on the standard normal distribution table, so we still need the z-scores to be rounded to the nearest hundredth. This z-score comes out to 1.4907, etc., so we'll round that to negative 1.49. So we know that we're looking for approximately this area. If we look up negative 1.49 on the normal distribution table, remember that we look for negative 1.4, and then we go over to the column for 0.09. This shows us that corresponding value is 0.0681. Remember that this table gives areas to the left of any z-score. So we've just found that this shaded area is 0.0681. So we can conclude that the probability that 20 randomly selected runners will have an average finishing time less than 58 minutes is about 0.0681. A study involving the heavy use of smartphones showed the mean of the battery life to be 10.75 hours with a standard deviation of 2.2 hours. The battery then needs to be recharged. Find the probability that 70 randomly selected smartphones will have a mean battery life of more than 11 hours. Again, since we're looking for the average to be more than 11 hours, this is a probability in the sample mean distribution. So we first have to verify that the sample mean distribution is normally distributed. It doesn't say anywhere that the battery life of these smartphones is normally distributed. However, because we're looking for the average of 70, we know that n is greater than or equal to 30. N is 70 in this case. So the X bar distribution is normal, and we can proceed the exact same way we did before. So we know the mean of the original distribution is 10.75 hours. So the mean of the X bar distribution is also 10.75 hours. The standard deviation of the original distribution is 2.2 hours. So the standard deviation of the X bar distribution is 2.2 divided by the square root of n, and again, in this case, n is 70. So we get the standard deviation to be about 0.2629502941. What we're looking for here is the probability that a mean will be more than 11 hours. So we know that the mean is 10.75, and we need the z-score for 11. So we have 11 minus 10.75, again over the new standard deviation, which is 0.2629502941. So the z-score comes out to be 0.95075, etc. So we'll round that to 0.95. Again, we're looking for the probability that the mean battery life is more than 11 hours. So we're looking for approximately this area here. If we look up 0.95 on the table, we go to 0.9, and then over to the 0.05 column, which gives us 0.8289. Again, though, this table gives us areas to the left of any z-score. So 0.8289 is this area here. Since we're looking for the shaded area, we need to again use the property that the area under the entire curve is 1. So the shaded area will be represented by 1 minus 0.8289. So we get an area of 0.1711. So this tells us that the probability that 70 randomly selected smartphones will have a mean battery life of more than 11 hours is about 0.1711.